Alibaba Cloud, powered by AI, helps elevate Olympic broadcasting services, making viewing awesome. Alibaba Cloud, worldwide cloud services partner.
Did you see that?
More than a century ago, the first electric light bulb buzzed into life. The world was thrust into a new era. With electricity, we built televisions. We took back the night. With new industries and transportation, modern cities were born. Civilization was making leaps and bounds, and we entered the age of electricity. Today we are experiencing another once-in-a-century transformational event, the digital era. Digitalization has not only changed how we live and work, but has also given us the tools to explore a better future. Behind all this, like electricity, computer is the driving force of this era. I used to believe that the pen and paper were the most important computing tools in human history, and a vital part of human civilization. The invention of modern computers has replaced pen and paper. As cloud computing emerged, we gained the ability to obtain computing power anytime, anywhere. Since our establishment, Alibaba Cloud firmly believes that cloud computing is not an extension of traditional computer technology, but a start of the new computational era. Even if fancy hardware is out of reach for individuals, computing power no longer restrains the imagination of the people. Like electricity, computing power has become a new utility and can be used to your advantage anytime, anywhere. Today, cloud computing in urban and rural areas, on the ground, in the ocean, in outer space, and in more places that unknown to all, brings us unimaginable power. In this digital era, cloud computing unlocks the power of imagination, like how electricity powered cities in the 20th century. Cloud computing is redefining the world we live in. And all this is just the beginning.
Since 2016, the first global public cloud provider in Indonesia. 3 data centers and 1 scrubbing center, serving diverse industries. Footprint across Indonesia. Collaboration with Ministry for Digital Talent and PR release with our key account customers, empowering businesses, driving digital transformation. Join the journey with Alibaba Cloud Indonesia. We achieved quite a lot starting with our Developer Summit, hosting the successful Database Summit, encouraging innovation at our AI Hackathon, exploring future technologies at the Apsara Conference, supporting a wide range of industries with our cloud solutions, celebrating partnerships with events and collaborative projects, expanding our reach across Indonesian universities and training centers, 120,000 trainees per year, 2 times more comparing with last year, partnering with the government on key projects for digital transformation, representing Indonesia on the global stage, enriching our ecosystem with AI and nurturing digital talents.
As technology evolves, we're reinventing what cloud can offer the world. Computing, the heartbeat of technology. Now it transcends mere calculation to learn, to think, and to create, for groundbreaking ideas to thrive. We've built a playground for large language models and innovators alike. We've established a global infrastructure empowering innovators to enter new markets while riding the crest of the AI wave. Neo, even newer than new, signifies the transformative power of AI on the cloud, permeating the economy and reshaping industries for the better. We're revolutionizing financial services with stronger security and more streamlined operations, heralding a new era of efficiency and trust. We're redefining retail with a radically transformed consumer experience and unlocking smarter productivity benefits from factories to society. In the nexus of our cloud and AI, we're linking and empowering businesses, communities, and individuals. We've joined hands with our local partners to open up more opportunities for local developers and startups. We believe technology holds the key to powering up sustainability. Above all, we believe in investing in our most valuable treasure, the infinite potential of the human mind.
My name is Chris Yeo and I'm the CEO of Doku. Doku is one of Indonesia's leading payment technology companies and has pioneered digital transactions since 2007. We help more than 150,000 merchants to accept payments and serve more than 5 million users. We are also the only payment technology company that holds complete licenses from Bank Indonesia. Through our capabilities, we can provide the widest product ranges to cater to the needs of various businesses, from enterprises to MSMEs. We aspire to spearhead the transition to a cashless economy, seamlessly connecting transactions and fostering economic growth in Indonesia. As a payment technology company, Doku is under the purview of the Central Bank of Indonesia and needs to comply with mandatory financial regulations. One of the requirements is to maintain a reliable disaster recovery plan. Thus, we need a dedicated and highly reputed cloud partner who could also provide various services to help us overcome our IT infrastructure challenges. The Bank Indonesia regulations also require the disaster recovery site within Indonesia. Hence, we need access to world-class data centers in the country certified with local and international standards. In addition, Doku required a cloud provider with substantial knowledge and technical know-how in solving the problems of Indonesian fintech businesses. In Doku, we also wanted to move from our on-premise IT infrastructure model to a cloud infrastructure, which would help us to shift from a CapEx to an OpEx model and gain significant cost optimization benefits. With this transition, the company envisions maintaining a stable and robust production environment while complying with regulations and efficiently controlling infrastructure costs. Alibaba Cloud has a strong presence in Indonesia with 3 world-class local data centers and 1 scrubbing center. Therefore, Doku could rely on Alibaba Cloud for its production and disaster recovery requirements. It provides an uptime guarantee up to 99.975% with high availability capability. It's backed by service level agreement committed by Alibaba Cloud. Additionally, Alibaba Cloud offers auto-scaling capabilities to dynamically provision and deprovision cloud resources based on workload demands. Alibaba Cloud keeps improving and adding innovative solutions to help us reduce the time and effort spent on operation and management of our IT infrastructure, at the same time allowing us to manage our IT spending budget more easily. This is why Doku chose Alibaba Cloud as its preferred cloud partner.
Doku has implemented a hybrid cloud architecture by connecting its on-premise infrastructure with Alibaba Cloud. It leverages Alibaba Cloud Express Connect service to establish secure and reliable private connection between its on-premise and the cloud environment and achieve high network throughput and low latency. In a phased manner, we use Alibaba Cloud Container Services for Kubernetes ACK to adopt microservices architecture for its primary services and business application. In Doku, we also employed Alibaba MQ for Apache Kafka to interconnect multiple applications in the hybrid environment and facilitate secure and controlled communication among various business applications. Being a PaaS service, Alibaba MQ for Apache Kafka helped the company minimize the need to maintain the underlying infrastructure on the message queues. The group adopted ApsaraDB RDS for database management for Redis, MongoDB, and PoloDB. It helps them benefit from increased stability and the built-in high availability option. This freed the company's personnel from many typical database management activities and help implement a robust disaster recovery strategy. Doku continues to phase out its on-premise infrastructure and plans to transition most of its workload to Alibaba Cloud. It is an essential phase in our strategy to focus on its core payment solution that empowers Indonesian cashless economy. Ultimately, we at Doku are delighted to successfully start its digital transformation journey and entrust Alibaba Cloud services and solutions to deliver more excellent value to our user and business partners. Yes, we can.
Mekari is a leading Indonesian SaaS company. Our mission is to power growth of business of our clients. We provide solutions and services that automate business operation from HR to CRM. We support millions of app users and thousands of companies from small, medium to large end enterprises. Mekari wants to continuously deliver innovation that will drive the digital transformation of businesses in Indonesia. To deliver innovation, Mekari needs to predict resource demand by maintaining flexibility and scalability to ensure resources are available when needed without the risk of overcommitting or over-provisioning. We are also continuously expanding as a company, and it's very vital for us to optimize our infrastructure spending while maintaining our growth trajectory. As a local company, we also need to make sure that we help our users to comply to local regulation. Therefore, Mekari has partnered with Alibaba Cloud, our advanced technology partner that offer us solutions that will give us consolidated view of our spending and budgeting across multiple business units, and all within a local regulatory framework. We choose Alibaba Cloud because of its strong presence in Indonesia, with multiple world-class data centers that provide the infrastructure that we need. Alibaba Cloud offers flexibility within its dynamic resource scaling, allowing us to deploy, change, and release resources without penalties during fluctuating demands. Alibaba infrastructure services like ApsaraDB, RDS, ECS, Kubernetes, and Cloud Firewall help us streamline our operation while ensuring compliance with local regulation. We also use Alibaba Cloud local regulatory compliance capability that have made us easier for us to fulfill requirements without the need for on-premise servers. We use Cloud Hardware Security Module, or HSM, and Cloud Firewall to secure confidential customer information. With Alibaba Cloud, Mekari has implemented solutions that have enhanced our operation. Alibaba Cloud's auto-scaling has helped optimize resources during peak hours and helped reduce our infrastructure costs by at least 30%. ApsaraDB RDS and container services for Kubernetes has allowed us to adopt microservice architecture, improving our service performance by 50%. Alibaba Cloud also has helped reduce latency by 60%, enhancing our customer experience, especially with the ability to scale resources at short notice. Mekari will continue to innovate our solution and services in order to serve our customers better. We will continue to work with Alibaba to tap into their latest innovation in big data and generative AI. This will allow us to provide even more value to our customers and strengthen our position as leader in SaaS solution in Indonesia. Alibaba Cloud's evolving technology will support us as we scale and expand into the market.
Xendit is a financial technology company that provides payment solutions. We simplify the payment process for businesses in Indonesia, the Philippines, and Southeast Asia, from SME, startups, and large enterprise. Xendit enables businesses to accept payments using direct debit, virtual account, credit and debit card, e-wallet, retail outlet, and online installments. As the first ever Indonesia startup to graduate from Y Combinator and backed by investors from Silicon Valley and Asia, Xendit powers some of the South Asia fastest growing brands including Traveloka, TransferWise, Wish, and Grab. Since the number of our customers grow rapidly, Xendit requires reliable infrastructure platforms, which has the capability to scale seamless, easy to operate, and to integrate. Xendit is looking for long-term solutions with innovations, agility, and flexibility. We seek a trusted cloud provider in Indonesia. Alibaba Cloud provides us with 99.95% high availability backup with SLA, offers elastic scaling capabilities to allow us to dynamically provision and do provisions in the cloud based on our workload demands. That's why we trust Alibaba Cloud to run our infrastructure operations.
We know that Alibaba Cloud has helped numerous local fintech companies in Indonesia. This experience from Alibaba Cloud gives us confidence for them to support Xendit to deploy our workloads and grow our business quickly and smoothly. Alibaba Cloud also provides innovative solutions that help us to reduce the time and personnel required to manage our IT infrastructure. Xendit relies on Alibaba Cloud infrastructure as a service.
Ladies and gentlemen, our distinguished guests, may we kindly request you to proceed to the main ballroom as our program will begin shortly. And we kindly request everyone to take your seat and please ensure that your mobile phones are set to silent or vibrate mode. Thank you, and we hope you have a wonderful time at today's event.
And transactions. Xendit also use Alibaba Cloud Key Management Service or KMS to encrypt and protect our sensitive data. Xendit plans to continue and grow our operations in Alibaba Cloud and to seek opportunities for using more innovative services and solutions offered by Alibaba Cloud.
Dana is a leading digital wallet provider in Indonesia. We are a platform that connects consumers, merchants, banks, and financial institutions to provide services like money transfer, bill payments, as well as payment for transactions that are online and offline. For about 2 years in operation, we've been serving more than 40 million users and 200,000 merchants. We serve about 3 million transactions per day. We need a system and infrastructure that can deliver that kind of scalability. For some workloads, due to regulations, we have to run on-prem. However, for some other workloads where we also need to scale, we cannot really rely on an on-prem. We need to go to the cloud to be able to really scale out. Alibaba Cloud came to mind not just because of their expertise, but they also have a presence in Indonesia that is very suitable for our solution to deliver to our customers.
We start playing with Alibaba Cloud when we deploy our new data viz tools. After we get more experience and familiar with the UI, integrating our satellite application. Since then, we explore more features and we deliver more services and give better values to our customer as well as merchant. Dana loyalty programs was created for the customers. Every time the customers do a transaction, they will earn some points. Instead of providing a physical card, we store virtually in our application. By doing that, we improving our user experience. Compliance, reliability, scalability was very important for loyalty and merchant portal. Our users and merchant are growing rapidly. By leveraging cloud computing, our team can focus on developing a new system, a new features, rather than tinkering the infrastructures and the complexity within. Cloud computing is especially cost-efficient and operationally effective during promotional campaign. By using Alibaba Cloud Container for Kubernetes, we can easily auto-scale resources and support large traffic volumes. Data analytics is also vital to Dana's business intelligence. Powered by Max Compute and DataWorks, our merchant portals provide an intuitive dashboard so merchants can access their specific analytics insights whenever they need it. The ability to now process large amount of data from different sources simultaneously offers Dana a host of new business possibilities at a greatly reduced development time. In fact, security is always a crucial factor for us and the basis of gaining people's trust when it comes to cashless transactions. To ensure that part, we are using Alibaba WAF, Anti-DDoS, and Security Center. We can reinforce security using the latest technologies without the hassle of managing them in-house. Cloud security is the most cost-effective way to identify potential security threats and ensure convenience and peace of mind for our customers.
2020 has been an exciting year for us. We've shipped a lot of features, and some of those are Dana Food and Easy Eats that runs primarily on Ali Cloud. We could deliver that in Ali Cloud within just weeks. Our vision for the future is to develop financial services on top of the existing payment services infrastructure. And to help building the cashless society of Indonesia, we are so excited that we are going to continue working closely with Alibaba Cloud to help us get there and deliver all these services to hundreds of millions of Indonesians.
Welcome to Flink Forward Asia 2024. Reflecting on a decade of excellence, we embark on a new era. Define real-time stream processing. Explore the frontiers of real-time computing. Apache Flink continues to innovate in data integration, analytics, cloud native, streaming lakehouse, stream batch unification, and data and AI. Enabling thousands of enterprises globally, Apache Flink is the de facto standard for real-time stream processing. Apache Flink, inspire innovation, leading the future of real-time processing. Flink Forward Asia 2024. Real-time is the future.
Good morning, ladies and gentlemen, our distinguished guests. Welcome to the Tamrinan Ballroom, Jakarta. And welcome to Alibaba Cloud Flink Forward Asia 2024. Ladies and gentlemen, this event is brought to you by Alibaba Cloud, and we highly appreciate your presence here today for an exciting and informative journey into the technological development, strategies, and breakthrough innovation in the Apache Flink system. Ladies and gentlemen, we have a packed agenda today featuring insight from Alibaba experts and industry leader. They will share their knowledge on various topics, including today's event to explore the transformative power of Apache Flink in Flink Forward Asia 2024. Real time is the future. My name is Dora Angela, and on behalf of Alibaba Cloud, it's very glad to accompany you today at this amazing event. And I hope you are as excited and deeply interested in this event as I am. For the first one, I would like to extend our heartfelt thanks to the key players who have made this event possible, ladies and gentlemen. Flink Forward Asia 2024 is proudly organized by Alibaba Cloud. Their commitment to delivering value beyond computation truly sets this stage for our discussion today. We would also like to acknowledge the original creators of the Flink Forward Conference, Ververica. Their vision of a unified streaming data platform empowers to drive insight, make informed decision, and act on data from any source. And here's our main session agenda that you can see in the LD screen. And we also have a social media challenge, hashtag MyFlinkMoment Challenge. So share your link forward agenda 2024 highlights and unique perspective with the community. Stand a chance to win exclusive Flink Forward merchandise. We have an exclusive Flink Forward gym bag for the top 5 posts. Can we give a big round of applause? Hope you have that gym bag. Gym bag. And also for the another 100 posts, we have stylish Flink Forward mug for you, special. And you have to upload it to the social media. Ladies and gentlemen, here's the step. Follow at Flink Forward Asia and at Alibaba Cloud on your LinkedIn or X Twitter. Share a photo or video from this event. Share your content on LinkedIn or X Twitter. use hashtag. There are 4 hashtags. The first one is Flink Forward, and then Apache Flink, Flus, and also Apache Paimon. Tag and follow Flink Forward Asia and Alibaba Cloud on LinkedIn or X Twitter. Fill out the official challenge form. The link is in the flyer at our booth. And include the link to post in the form. The challenge deadline is today, 3 p.m. And the winner will be announced also today by email at 5 p.m. Please note that, and you can claim your gift in our booth. There is also a feedback form, ladies and gentlemen, at the end of this main session that you have to be filled out. It can be exchanged for the merchandise at the registration desk at the end of the breakout session. All right, ladies and gentlemen, to kickstart our event today, please join me in warming opening for this event, Mr. Rocky Liu, as Regional Solution Architect Director of Alibaba Cloud South Pacific and Japan region, to share a few words and officially inaugurate today's proceeding. Ladies and gentlemen, put your hands together to Mr. Rocky Liu.
Good morning, ladies and gentlemen. It's an honor to welcome all of you to Flink Forward Asia 2024, hosted here in the vibrant city of Jakarta. Today makes a significant milestone for the Apache Flink community and for all of us gathered here as celebration 10 years anniversary of Apache Flink. At Alibaba Group, we've been proud pioneers investing heavily in Apache Flink and helped to shape the foundation of what has become one of the most impactful global communities in data streaming and big data processing. Over the last decades, Flink has evolved into a tool of unparalleled power, transforming how we handle and processing the real-time data. Well, Flink origins are global. I want to emphasize how Asian developers have been central to its growth. Our creativity, expertise, and collaborative spirit has not only fueled the project, but also inspired new possibilities for its future. This year, Flink Forward Asia breaks new ground for the first time since its launch in 2018. The event expands into Southeast Asia, and we are thrilled to host right here in Jakarta, Indonesia. This reflects that the region's growing importance in the tech ecosystem and its role as a hub of innovation, collaboration, and digital transformation. Flink Forward Asia 2024 makes a pivotal moment with the unveiling of Apache Flink 2.0. The release of Apache Paimon 1.0 and the launch of Flus, an open-source next-generation streaming storage solution. These updates are more than just milestones. They address critical challenges in real-time data processing, enhance data lake management and AI integration, and refine the scalability in the streaming storage. Together, they demonstrate that the continuing evolution of cutting-edge technologies and empower business to unlock new possibilities in the fast-paced world of the data. We are privileged to have an incredible lineup of Flink and big data experts joining us from across Asia and around the world. Companies like Mekari, AI Router, Uber, Lalamove, Platformatory, and Ververica, Ocean-Base, Confluence, and Decodable will share their experiences, inspiring us all to think the bigger and innovation together. At Alibaba Cloud Indonesia, we are committed to nurturing local digital talents through partnership with a university like University Indonesia and Venus University, collaboration with the government where ComInfo and Prakerja. And engagement with startups, we have reached over 8,000 developers in under a year. Our investment doesn't stop there. We firmly believe in openness, supporting open source community, empowering local partners, and build solutions together that address a unique challenge and opportunities in this region. As we celebrate the Flink's 10th anniversary, let us also celebrate the community that has made it all possible. This event is a testament to the power of collaboration, the boundless potential of technology, and the bright future and line ahead for all of us in the Flink ecosystem. Thank you for being a part of this journey. Thank you for coming to today's event. Let's innovate, share, and inspiring each other to reach even great heights. Lastly, enjoy the event, and thank you very much again.
Thank you to Mr. Roqueliu for that inspiring opening remarks. Can we celebrate the 10th anniversary of Apache Flink together by put your hand above your head 3 times together? Yeah? Yeah, can we do that? Together from the left to the right. 1, 2, 3. Boleh tepuk tangan 3 kali di atas kepala bersama-sama untuk kita boleh celebrate 10 tahun anniversary-nya dari Apache Flink ya. Boleh Bapak Ibu ya. 1, 2, 3. Once again for the social media. 1, 2, 3. Thank you very much and happy anniversary for the Apache Flink and also for the commitment to nurturing the local digital talent and investing to support open source community. So, ladies and gentlemen, for the next one, we're gonna have a welcome remarks. He's gonna share about the past, present, and future of Apache Flink. He's gonna tell us about the history, what we've done, and also what's in the future. So for that, I would like to invite Mr. Fung Wang as head of Open Data Platform, Alibaba Cloud, Apache Flink Committer, Apache Paimon PMC member. Put your hand together for Mr. Fung Wang.
Hello. Good morning, everyone. I'm Feng Wang from Alibaba Cloud. So first, welcome to Flink Forward Asia. I think this is the first time for Flink Forward come to Jakarta, the Southeast Asian country. So we're glad to see so many local developers here, so many passions. Yeah, I'm really excited. Yeah. So I think everyone knows that Apache Flink was born in 2014, yeah. So this year is the 10th anniversary of Apache Flink. So today, taking this opportunity, I want to share the overall evolution history of, sorry, that's me. It doesn't work? Sorry. Okay. Right, yes, right. Doesn't work. It doesn't work, no? Oh, okay. Reverse. Yeah. Yeah, okay. Cool. So today I want to share the evolution history of Apache Flink, as well as the current situation of it. And in the end, I think I also want to review some new directions of Apache Flink for the next decade. Okay, so first let's recap the remarkable milestones of Apache Flink in the past decade, from which we can also see how Apache Flink drives the evolution of data technology from offline processing to real-time processing. Okay, so I think similar as Apache Spark, Apache Flink also originated from a research project in university, which was named the Stratosphere in 2009 in TU Berlin, Germany. Yeah. So after 5 years, in 2014, the core team of Stratosphere donated to Apache Software Foundation and renamed it to Flink. Then established a company around it named the Data Artisans. Yeah. Now we call it Verrica. So that is the origin of Apache Flink. So during the same period, in other side of the planet, Alibaba Cloud, Alibaba Group also has been fast growing for many years. So there are about more and more data generated on Alibaba e-commerce business platform at every moment. So in order to explore the next generation of data platform which could process the data in real-time mode, we do some researches, studies, and investigations, some experiments. Finally, we choose Apache Flink as our unified streaming technology processing engine, among various different kinds of open source projects. Then, with some efforts, we finally put it into production in 2016. Yeah, this is the first time large-scale production of Apache Flink. Yeah. After the big gain from Apache Flink, from the business perspective, Alibaba Group also decided make a big decision to want to contribute more, contribute to it. Yeah. So you can see that in 2018, Alibaba firstly organized the Flink Forward Asia conference in Beijing, which is aimed to boost the adoption and the popularity of Apache Flink in China. Yeah. And in the second year, in 2019, Alibaba decided to further reinforce the investment to Apache Flink. Then announced the acquisition of Data Artisans, the founding company of Apache Flink, and then renamed to Verrica. Yeah. In addition, Alibaba also make another big decision to contribute its in-house Flink version, which is also a production-proven Flink branch. We name it Blink or Blink to the open source Flink community. Yeah. This is a very huge contribution, which involved about 1.5 million lines of codes. Yeah, it's very huge work. It take the team. I think we spent about 40 engineers to work on it. I think after this contribution, Apache Flink really got production ready globally, and this contribution accelerated the Apache Flink community become more and more mature as in the world. So you can see that in 2023, the Sigmod, I think it's the top level organization in data management area, awarded the annual system award to Apache Flink, which means Apache Flink has been acknowledged by both industries and academia at the same time. So, also at the beginning of this year, Alibaba Cloud again contributed another project named the Flink CDC, a real-time data integration tool to Apache Flink community as a new sub-project of Flink. Yeah. And successfully incubated a new project named Apache Paimon from Flink community, which is a real-time data lake format project. So that we can see from in last decade of Apache Flink, Flink has been, in last decade, Flink has been widely deployed in the world. Yeah. Flink firstly originated from Europe, then propagated to China, to US, and many other countries in the world. Yeah. So far, there are about nearly 2,000, I think, 2,000 contributors for Apache Flink globally. So from the geographical distribution, we can easily find out that there's nearly about half of the contributors come from China. Yeah. Why? Because of the big population base of China. Maybe it's one of the most important factors, but it cannot be denied that Alibaba played a really played an important role, crucial role for it. Since 2018, Alibaba began to organize Flink Forward Asia in China. I think this is the 7th time. We have never stopped it, even during the pandemics. We organized 2 Flink Forward Asia online. Yeah. So even if it's the 7th time for Flink Forward, but it's the first time outside China. So in the future, in my opinion, I think we can see more and more Flink Forward Asia conferences happening in many other Asian countries, cities outside China. Yeah. Okay, so in my opinion, the reason why Apache Flink could be acknowledged by most of the developers globally is that it really has met the trending demand of real-time data analytics from market in recent years. Yeah. As we know, most of the decision makers in enterprises hope their business report could be updated in real-time mode in seconds, yeah, rather than T+1, yeah, which could help them to make decisions more in time and more efficiently. And for the financial enterprises, I think they want all of the risks could be detected in real-time mode, in seconds, even milliseconds. Otherwise, maybe minutes or hours of delay may cause money loss. Yeah. Also for the e-commerce businesses, big companies, they also hope their search ads system could recommend the more suitable products to their product customers. Yeah. Based on the real-time interactions between their customers and their applications. Yeah. So Apache Flink as a streaming data processing engine, a real-time computing engine, exactly help the company to solve these kinds of problems. So in other words, Apache Flink really got the project market fit in the last decade. Okay, so we can see that in the past decade, Apache Flink has widely adopted and deployed globally in many different kinds of companies, various of industries, and most of the times will be chosen as a default stream engine. So we can see that Apache Flink has already become the de facto standard of real-time or streaming computing engine in the world. I think after about 10 years, technical evolution, Apache Flink has become not only the best streaming computing engine in the world, but also an excellent unified engine for both streaming and batch. That means the customers, the developers could use Apache Flink to process all kinds of data, including the bounded data and the unbounded data. Furthermore, Apache Flink has already been seamlessly integrated into the current big data ecosystems by its rich connectors. So the developers could use Apache Flink to connect most kinds of the data storage systems in the community. I think including the mainstream databases, data lakes, data warehouse, messaging queues, search engines, etc. Yeah. So to some extent, we can see that Apache Flink has become the backbone or the data highway in current data ecosystem. Okay, next, let's deep dive into the biggest upgrade of Apache Flink in recent years, from streaming compute to streaming lakehouse. Yeah, I think everyone knows lakehouse. This is a very hot topic in the world, both in North America and in China. Yeah, so lakehouse has already been considered as the next generation of data architecture. So since 2 years ago, in 2022, Apache Flink community began to incubate, to explore this new area, and incubated a new project named the Flink Table Store inside the Flink community, which is a kind of real-time or streaming-oriented data lake format. Then, in the next year, we spin it off as an independent project and donated it to Apache Software Foundation. Again, renamed it to Paimon. Yeah. So through the integration of Apache Flink and Apache Paimon, both of them are streaming-oriented design. So the users could build a new type of new generation of data lakehouse, a real-time lakehouse. We name it as streaming lakehouse. Yeah. In streaming lakehouse, the customer could use the Flink CDC, this tool, to inject the data from external data sources into lakehouse in real-time mode. Then use Flink SQL to process data or cook data in lakehouse in both streaming and batch mode. That means we can do data pipeline, real-time data pipeline, and offline data pipeline. Yeah. So in summary, streaming lakehouse is the upgrading or upgrade of the lakehouse architecture. Is a real-time lakehouse architecture. Yeah. Yeah. So users could inherit all kinds of benefits, advantages from a lakehouse architecture, but also bring more real-time and unified experience to the customers. Of course, this new kinds of technology and new real-time architecture has been deployed successfully in Alibaba, especially on this year's Alibaba's Double 11 Shopping Festival. Yeah. By leveraging these new kinds of real-time data analytics architecture, the Alibaba's BI team or data team could use one unified SQL, Flink SQL, to build the stream pipeline and the batch pipeline at the same time. Just write the SQL once to describe the real-time and the offline business pipeline. And also, the user could use one data storage system to store the data, to manage the data, without the data copy from different kinds of data systems. For example, don't need to move the data from Kafka to Hive. Yeah. So this means we could reduce the complexity of the data architecture and save the cost at the same time. Yeah. Of course, make it real time. It's okay. The last part is about the future of Apache Flink. Everyone knows that Flink 1.0 was first released in 2016. Yeah, I think 8 years ago. So after the 10 years anniversary, Apache Flink community will start a new era with the next generation of Apache Flink. Yeah. That means we will formally release Flink 2.0 in the near future. Maybe in the next, I think maybe in next 3 months, in the beginning of 2025. Yeah. There are a lot of features, so many features and improvements in Flink 2.0, this biggest upgrade in recent years. Due to time, I just want to share the major 3 changes in Apache 2.0. Yeah. The first one is about the core architecture. Flink is a stateful streaming engine. So state is a very core concept of Apache Flink. So in Flink 2.0, the disaggregate storage architecture will be production ready, totally production ready. That means users could get better experience for elastic and serverless computing by Flink, and better experience for fault tolerance. Yeah. So in one word, Flink architecture will be totally cloud native. Yeah. Second one is about the unified SQL for data analytics. Although currently Flink 1.0 could provide the unified SQL to support both streaming and batch processing, but users need to do some manual configures. Sometimes it is complicated and difficult. So in Flink 2.0, we simplify it. Users just need to declare or define their business logics and the specific data freshness. For example, write a SQL to read two tables and join two tables, then do some migrations and insert into another table. And define the data freshness for it. How long it will be updated. For example, 1 minute, 10 minutes, or 1 hour. Then Flink engine will take over it and make a decision to use the right runtime mode to execute it automatically. Yeah. The last but not least is about AI, because AI is eating the world now. Is maybe is the most hot topic in the world. So in Flink 2.0, we will add more AI functions into Flink SQL to help Flink could better interact with the AI system. For example, for the large language models, for the vector databases, etc. Yeah. I think in the next section this morning, there are dedicated topic about Flink 2.0 by the release manager of Flink 2.0 in the community. I hope you can get more information, more details from it. Okay, that's all for my today's talk. In the end, I hope in the future we can see more and more local development from Indonesia and the Southeast Asian countries join Flink community to co-build the open source project. Thank you.
All right, thank you, Mr. Feng Wang, for the opening remarks about the past, present, and future about the Apache Flink. So the 2.0 is coming. Let's be ready, ladies and gentlemen. For the first one, we have a case study, Mekari case study that will be delivered by Mr. Fajar Tontowi. He is a lead data engineer in gestation and analytics who will enlighten us about implementing CDC to max compute with Apache Flink. So please welcome Mr. Fajar Tontowi.
Okay, morning everyone. My name is Fajar and I'm from Mekari. Today I will present to you about what improvement we do on Mekari with serverless Apache Flink and Ali Cloud and with max compute for our data sources. Okay, for the beginning, I will introduce to you about Mekari first. Mekari is one of the largest company in Indonesia that provide some services to help other companies to grow in many areas. We have 6 major product and services Mekari. We have Talenta, Journal, Klik Pajak, Flex, Kontak, and Design. It will be help to company to grow in many areas in certain area. So today we have 800K registered user on Mekari, 35K business connected to Mekari, and we operated in 20 cities around Indonesia. Because on that, on daily basis, based on our user, we have more than 4 terabytes of data need to be processed on daily basis in a real-time and batching processing. And also because we have several products that I mentioned before, we have journal and etc. For the connecting the data from the backend to our environment of the data, we're using CDC. And currently we have like more than 800 table being processing using CDC in our pipeline. And also there is more than 40K event is generated per second. It's come to CDC event or any our microservices in Mekari. So this is the legacy architecture in Mekari. We have previously we using AWS as our cloud services. We have some of data sources like relational DB, third party, file, non-relational DB, and external data. For relational DB, to connect all the database from all our product, we're using CDC. So like I mentioned earlier, from the CDC data, we sync the data into our data lake. In our data lake, we separate the zone in 3 zones. We have a raw zone, validated zone, and analytic zone. Raw zone means all the data from the sources will be put into the S3 in the format as it is like in the sources. So if the sources, the data is from CSV, we'll be put the raw zone as a CSV file. Also if PDF, JSON, and Parquet. For CDC data, we sync the data to raw zone. In Parquet file contain metadata from DBZium. So the Parquet file will be contain the data from DBZium. After that, there is validated zone. In validated zone, basically, we do some cleansing of the data from the raw zone, standardize the data, and do some of the duplication of the data, and put all together in the validated zone in standardized format in Parquet file. And after in validated zone in Parquet file, BI or analytic teams can do some creating some data mart or data warehouse, using Athena to query to the validated zone. For data processing engine, we have to EMR, Athena, and Python. So data from the raw zone and validated zone to do processing, transformation, standardize, and cleansing, we use EMR and Spark on that. So will be Spark or job will be running on the EMR to do the processing of the data from the raw to validate. We have one big cluster EMR to serving all the product in Mekari. So the data orchestration we use is Airflow to manage the workload and the jobs to sending data from raw, validated, and data mart or data warehouse. And we're using S3 as our storage engine. We pull all the data into the S3. So this is the, we have some BI tools also. We have a connected Athena with a Tableau and Metabase, and also API for external data if some of customer want to pull our data, they can use API we created, and also machine learning for predictive modeling from data science team to create a model from our data in a data lake. Okay, next, what is the challenge of the old architecture? First is about cost inefficiency, because when of the largest of the data is coming, our usage is growth, the data always increment on daily basis, the expensive of architecture when we need to more resources in EMR. So like I mentioned before, we use one EMR cluster for serving all the product to processing like a standardized and deduplication and anything. We use EMR cluster. So we need always vertical increase the resource in every day if we need some more resources. And the cost of the EMR is so huge and it's not efficient of data volume increment on daily basis. So the second is hard to calculate the resource needed for every product. Like I mentioned before, in Mekari we have several products. We have Talenta, Journal, and etc. And because we have one EMR cluster, it's difficult to us to calculate how many resources or how many costs for we processing data from Talenta, from Journal, and for any other product. So because we in previous architecture, we just only one F1 cluster for all the products. And the second is about alert and monitoring data issue. Because if there is some, we always have been issue like data discrepancy, right? In data warehouse and data mart layer, we always be facing of the data discrepancy. So if the data discrepancy occurs in data mart layer, it will be difficult to see the root cause if the issue is happen in the raw zone, because in the raw zone is the data is still on the format like any sources. So the format can be CSV, PDF, JSON, etc. So it will be difficult to us to find the issue in the raw zone. So and also it's difficult to us because not standardized of the format from the raw until the validate until the data mart and data warehouse. We having challenge to create some monitoring alert for discrepancy, and we talk about data quality issue, nullness, any other metrics of data quality. We want to maintain data quality from raw until the data warehouse is clear. It's also we have some challenges on that. So, and the third is about real-time analytics. If we want to create some real-time analytics, currently we having some difficulty, like because in real-time data is stored in the raw zone data, and in the raw zone data it's still formatting on the different data type like JSV, JSON, and etc. So it's difficult to analytic to query directly on that. So it's so challenges and difficult to create real-time analytic on the legacy architecture. And because the data is not yet standard from raw until the data warehouse, it also make some difficulty on that. So this is the interesting part. This is what the new architecture of we do in Mekari. We using Ali Cloud services for our cloud service, and we use Max Compute for our data store, and we use Flink serverless on Ali Cloud service. We use Apache Flink on Ali Cloud service. So basically this is Flink with manageable service by Ali Cloud. So the difference is about the legacy architecture. With the new architecture is all the zone is already standardized on the table layer. So in the raw zone until analytic zone, the format is on table and data will be stored on the table. From relational DB to raw zone, we use Apache Flink for connect CDC data from our sources like in MySQL and Postgres. We deploy the data using SQL deployment in Flink, so it will easy to us to connect the data from DB, MySQL, and Postgres, because we just need to store the SQL deployment and create some SQL script to put the data, to sync the data from the relational data to raw zone table. In raw zone table is data already formatted on table, so all the data already can be queried by from analyst or BI team. And on validated zone, analytic zone, it's same zone like before, but difference is just the format is only on the table format. And we use data processing engine Max Compute. We processing the data using query on all the process. From the raw zone, we process the raw zone from validated zone. We do some cleansing of the data, standardize the data, and deduplication of data with the query. It's making easier the process because we just need tweaks the query if we want to do some processing of data from raw zone to validated zone. Okay, this is the new architecture and the improvement we do on Mekari. The process, so the advantages of the current architecture is cost effective because in Flink, we can distribute the resource based on our product. Like if journal need more resources, we can put the more resources in journal. If Talenta need more resources, we can also put more resources in Talenta. It's possible do in Apache Flink to on that. So and it will make easy to us to scalable the data also, and and make easy to us to calculate the cost for each product, because sometimes we need to calculate the cost based on the product we have. And second is performance and scalability. Because of the connection, currently we just use CDC and Flink, so we cut some of the process and we just need some of SQL deployment to creating some SQL script to deploy in SQL deployment. and will easy data from the CDC like Postgres, MySQL, and any other RDS sent to Mexquery. And also, we doing with autopilot mode in our SQL deployment in Flink. So when some spike data event in any other activity in backend, so the Flink will be automatically increase the resources of the SQL deployment. So it will be easy to us if there is some peak data event in sometimes they will automatically increase the data. So it will be easy to manage the server and infrastructure in for data engineering teams. And the third one is real-time analytics. So many our clients is asking to us to make a real-time dashboard for them because they need real-time analytics for making some decision about churn or anything they need. So currently with the new architecture, we can do real-time analytics. We can do the transformation on real-time basis on the Flink. We can do some query on the Flink SQL development directly to the RDS and put directly to our analytic zone like data mart on data warehouse. So it will be help stakeholder to their company growth with real-time analytics. So the impact on technical benefit automatically scale on Flink is make us our easy to maintain the workload of the job. It's easy to us to not always monitoring the job, right? Because it will easy if we have a feature like autopilot in Flink, it will easy to us to performance the issue. So, and the serverless architecture remove need for infrastructure management, allowing team to focus on platform development. Serverless architecture make us to easy to deployment some infrastructure. So, like I mentioned earlier, we just need to put some SQL script and SQL deployment. We cannot build some monitoring alert or etc. We can use monitoring alert in Flink services or Max Compute services. So it will easy to us to maintain the serverless infrastructure. So our team can be more focused on platform development to make our platform can be more easy to use and can be easy to our customer to check the data and the fastest readiness of the data. And the third is a integrated end-to-end solution from data ingestion to analytic environment. So the data integrated end-to-end solution from the RDS until the our analytic zone is using Alibaba Cloud Services, and we have like centralized monitoring on that and centralized monitoring alert on that. So it will easy to us to having some notice some issue if there is some data error or some anomaly data, it's coming from raw, validate, or our CDC infrastructure. And from business perspective, there is some benefit also. We have, with the new architecture, we have a cost reduction on infrastructure about 30 until 40% because we do some efficiency and resources like I mentioned before. We make every product have efficient resource, so there is not leak resources on every product. And also we maintaining the CU or compute unit on the Flink correctly and manageable in Flink. So we can manage cost reduction of infrastructure until 40%. And also for the SLR readiness of our data is increased like 40%. Basically, our data can ready on like 8 AM until the data mart today. With this new architecture, the data of readiness can be ready on 6 AM. It's good for our customer because the more ready of the data, the more can use the data. Okay, the next part is about real-time data capability. We provide some quick insight because now we can provide them with real-time analytics. And also we collaborate with BI to create some dashboard real-time, and we can help the company growth with real-time data so they can make more faster decision with correct data in real-time basis. And the third is the flexibility of serverless of infrastructure, because the flexibility of the serverless infrastructure we deploy on the Alibaba Cloud, now we can focus and creating platform to our customer and our user. So it will be make easy to us to focus on the future long-term visibility, to see the opportunity to what can we growth and support other evolving technology in Mekari. Okay, I think this is my last talk about what we improve in Mekari from the legacy architecture to new architecture. I hope this can enlighten us to give some new information, and feel free to reach out to me in my email or link in social media. So if you want to some question or need something discussion about this, feel free to reach out to me. I will happy to share to you about everything what we do to improve our architecture. Thank you, everyone.
Thank you, Pak Fajar Tondowi, for the Mekari case study. That's what Mekari has implemented and also improved to the architecture that they feel benefit of technical and business faster, seamless, and also cost-effective, ladies and gentlemen. Next, we have a trio speakers for the next presentation on Apache Flink 2.0, streaming into the future. The first one, we have Mr. Sin Tong Song, as Alibaba Cloud Software Engineer Staff, Apache Flink PMC member, and Apache Flink 2.0 Release Manager. And together with Mrs. Yuan Mei as Director of Engineering Alibaba Cloud, Apache Flink PMC member. And all together with Mr. Lincoln Lee as Staff Software Engineering, Alibaba Cloud, Apache Flink PMC member. They will talk about the Apache Flink 2.0. Please, for the first one, please welcome Mr. Sin Tong Song.
Hello, good morning, everyone. My name is Sin Tong. I'm from the Alibaba Cloud Flink team, and I'm one of the Flink PMC member, and also I'm the release manager of the Flink 2.0. And today is my honor here to share with you about the Flink 2.0, together with my colleagues, Yuan Mei and Lincoln Lee, who both are the PMC members. Well, we have mentioned that the Apache Flink has joined the Apache Software Foundation in 2014, but the first formal version, the Flink 1.0 version, was actually released on 2016. And after that, the Flink has released many minor releases, and by minor releases, I mean like the 1.x releases like 1.17, 1.18, but we never released another major version. Well, in the past 8 years. And last year, we realized that as the Flink has been involved, a lot difference from when it was shaped as Flink 1.0, and we are facing more and more challenges. So to address these challenges, we need to make some significant architectural upgrade to the project. So we kicked off the planning for the Flink 2.0 in the community in last year, April. And the preparation of the Flink 2.0 takes quite long. We have been through 3 minor releases, the 1.18, 1.19, and 1.20. And finally, in this October in Berlin, Flink Forward Berlin, we just announced a preview release for the Flink 2.0 version. And the formal Flink 2.0 release is expected to be shipped in early next year. So we can see that the preparation for Flink 2.0 takes really long. It's almost 2 years from the from April last year to early next year. So the reason it takes this long is because we are making some compatibility breaking changes in this major version up, and we want to leave enough time for our users and for our partner projects to adapt to these breaking changes. So here is a summary of the breaking changes. We have removed some deprecated APIs, for example, the dataset API, the Scala datastream API, and some old connector APIs. And for the existing APIs, we also made some updates, like the datastream API and table API, and of course REST API, the Flink client and SQL client. And for the configuration, we have removed the old flinkconf.yaml file, and users can now use the new config.yaml file, which is strictly following the YAML standard. And we also removed some deprecated config options. And for the state, it needs to be noticed that the save point and checkpoint compatibility is not 100% guaranteed between the 1.x versions and the 2.0 version. Well, this is mostly because of we did some upgrading to the serialization framework of Flink. And the community is working on some tools to help our users to migrate between the incompatible states. And other things like we have dropped the support for Java 8, and the per job deployment mode will be removed in the 2.0 version. Well, we just mentioned that we are removing some old connector APIs. That means if there's some existing connectors which are using the old APIs, they need to be migrated to the new APIs before, in order to work with the Flink 2.0 version. So as a first step, the Flink community will work on the following 4 most commonly used connectors: the Kafka connector, Paimon connector, JDBC, and Elasticsearch. So this will be supported by the time that Flink 2.0 formal release is out. And for the remaining connectors will be supported gradually. And it's the community developers are more than welcome to join us in accelerating the adoption of Flink 2.0 for the community, for the connector ecosystem. Okay, so we have spent a little time on the progress and the breaking changes of Flink 2.0. And the remaining time of this talk will be focused on the technical highlights of Flink 2.0. And we are going to talk about 4 directions: the streaming, the stream batch unification, the streaming lakehouse, and the AI topic. So firstly, we want to talk about streaming. And for this part, I'd like to invite my colleague, the Flink PMC member Yuan Mei, onto the stage. So please, Yuan Mei.
Thanks, Xing. So, hello everyone. My name is Yuan, and I'm from Alibaba. I'm the Director of Engineering at Alibaba Cloud. And I'm also a PMC member of Flink. So, today I'm going to share some of the very exciting work that we've done in Apache Flink 2.0, and which is the disaggregated state management. Disaggregated state management enables Flink's cloud-native future. Let's start and how it works. So, this year is the 10th anniversary of Flink, after it becomes the top-level project of the Apache Software Foundation. Well, over the past decade, you know, like Flink has been blooming. I mean, like, it's been widely used in many different areas, and it's developed a rich upstream and downstream ecosystems. Well, ecosystems. So, Flink has become a de facto standard for stream processing in open source area, in academia, and in industry globally. Well, at its core, I think these three symbolic characteristics are still at its core of the Flink's characteristics, which is distributed in large scale, high performance, and stateful computation. What is stateful computation? For a stream processing system, the input is unbounded and continuous, generating the low latency output based on this continuous input. And the stateful computation basically means that basically means that some intermediate results of this stream processing. So for each input record, it has to access the storage, the intermediate results, and then generate the new output. Hence, state access latency is critical to performance. Well, remember, this is pretty important, and I will mention later why it is so important. Because of the state latency is critical, so in Flink, we co-locate the state store and the computation together, as shown in the middle graph. So state is snapshotted, has to be snapshot periodically, so that when we have a failure or we have to do the rescaling, we have to reload the state or redistribute the state. For systems like for distributed system, we have to make sure the snapshot is consistent. By a consistent snapshot, it actually means for each distributed node, it holds the subpart of the snapshot, that those subpart of the snapshot has to correspond to exactly the same input offset. So the procedure to make the consistent snapshots actually is a very well-known and famous Flink checkpoint procedure. Well, this tightly coupled architecture guarantees the high performance for Flink, but it to some extent hinders the expansion and the development of Flink, especially when the state size grows large, which exceeding the capacity of the local disk. And together with the cloud native training in the recent years, we actually have more challenges. If you could see, we summarize the challenges in these 4 parts. The first is computation and storage scale independently. Well, this is easy to understand, right? Because we do not want to pay extra money for computation simply because my state size grows large. And the second is containerization. Well, containerization is a commonly used technology in cloud native, and it requires predictable, smooth resource usage. So why it is a challenge? Because as I mentioned before, in the tightly coupled architecture, the checkpoint procedure is happening in a very short period of time, which boosting the resource usage in CPU, I/O, or network, which actually have a resource usage peak, make the entire cluster unstable. So this is a challenge in the containerization technology widely used area. And the third part is now the cloud storage like S3 OSS is commonly used and available. So how we can make use of such cheap and massive storages? They are highly available and scalable. And how can we make use of them? With the improvement of the hardware or network speed and bandwidth improvement, is it possible that we get rid of the local disk? Well, the last challenge is elasticity for stateful computing. We know that for stateless computation, rescaling is very fast and cheap. But for stateful computation, we have to redistribute the state across the stateful containers when we're doing the rescaling. So how we can accelerate the state redistribution, even if we could achieve the redistribution within sub-second, that's also a challenge for us. Well, this is our solution. That's exactly what we do in Apache Flink 2.0 in the disaggregated state management. And this is our solution, ForceDB. ForceDB, forced stands for for streaming. And ForceDB is the for streaming DB. And it's a very simple and straightforward name with very good willingness. ForceDB, I remember that. It's already open sourced. And we wrote it. So what is ForceDB? ForceDB natively supports writing to and reading from DFS. DFS is the distributed file system, like S3 and OSS, or simply HDFS. So how it magically just solve all these problems? Let's see it one by one. So first, state is no longer constrained by local disk, because now we can writing to and reading from DFS directly. And DFS, in theory, it could have like unlimited storage space, and not constrained by local disk anymore. Well, the second one is instant rescale and recovery is also possible right now, because now we can read from the DFS directly, so that we do not have to download the state when we're doing the recovery or rescaling. So the downloading time is saved. And the third is, well, now we actually have the working state and the checkpoint data writing to the DFS altogether. So underlying, they can share the same physical files. In that sense, we can make the checkpointing procedure lightweighted. Well, since I have already mentioned, the checkpointing procedure is actually generate the resource peak usage in the current tightly coupling architecture. So if we can make lightweighted checkpointing procedure, then it could smooth the resource consumption in a large way. Well, architecturally, you can see it's from the left-hand side of the graph to the right-hand side of the graph. Seems like it's just a very simple change, right? Just to replace the local disk to a DFS. And is that simple? Is that so simple? Oh, of course not, right? So then if it's that simple, it won't take 10 years. So why it is not that simple? The key fact here is, as I mentioned at the beginning of this talk, because the state access latency plays a critical factor for performance. And when we're accessing to the DFS, comparing access to the local disk, the latency is 10x time longer, which indicates that we will get 10x time performance drop, which is not acceptable. Now, if you just simply replace the local disk with DFS, you will get, what we will get is 10x performance drop, and the Flink is not usable anymore. But this is actually why the reason, for so many years, there are so many attempts to make the disaggregated storage, but there's no succeed. That's the reason. Well, the key insight here is the first one, the async execution, which is separating the CPU processing out from the state I/O access. This is very, very key insights how we can actually make the performance comparable to when we are accessing the DFS comparing to access a local disk. So the second point in the middle column I want to highlight is the checkpointing procedure. So for a streaming processing system, a native and a deep integration of database and the checkpointing procedure is have to be done. Otherwise, you cannot guarantee a consistent snapshot, and you cannot guarantee exactly once, and you lose all the benefits that Flink provides. And otherwise, if you do not have the deep integration, it has no difference that you are using an external database. So we made a lot of efforts in this part and also achieve native elasticity support. When the third part is the cache. Well, we all know that when we're using disaggregated storage, then the performance, the cache is critical to boost the performance. So if the local disk is not a must-have, but if we do have local disk optionally, right? So we should make good use of it. So we also make a lot of efforts to develop the hybrid adaptive tiered cache. Well, I do not have time to go to all the details, so I have a more detailed talk on the upfront. So if you are interested, then you could go to the link and see the more detailed talk about how this fancy stuff happens. When Flink 2.0 is expected to be released early next year, and in the blue box there are 6 major areas we're going to achieve in disaggregation. And as I said before, forced DB and async execution are the founderstones that make disaggregation successful. And the forced DB preview version has already been released 2 months ago. The link is shown here, and it shares some of the experiment results. And if you are interested, you could also have some end-to-end experience and play with it. And the former version would target for Flink 2.0. And they have the end-to-end support for Flink disaggregation, and they also have 70% SQL async OP support, and also support the SQL migration. Okay, so here are the list of flips, the Flink improvement proposals for the disaggregation. So if you are interested, and they are all public in the Apache Flink community, they cover all the details of the technology that I've covered today, just for your reference. And at last, I want to share some of the experiment results of the ForceDB preview version. And in short, all these experiments are all comparing to the latest version of Apache Flink 1.20. So I want to have 3 highlights here. The first one, so in the synchronous execution mode, this aggregation is 10x slower as expected. Well, what does it mean? It means that if you just replace the local disk with a DFS or use any kind of external database, that's the performance you will get. You will get 10x slower performance. Well, that's too bad. And what do we do? So, as we said, we introduced the async execution mode. So in the async execution mode, let's see how it works. The performance of disaggregate without any cache. Cache here means local disk. So in the async execution mode, the performance of disaggregation without any cache is comparable to Flink 1.20. By comparable, I mean 15% slower. Well, it's still slower, but comparing to 10x slower, it's much, much better. Okay, then what's more? Let's see the third one. So in the async execution mode, the performance of disaggregation with 50% of cache improves 50% comparing to the Flink 1.20. So what does it mean? So that means with only half of the local disk, now we actually achieve 50% better performance than before. So that's amazing, right? So if you're interested in how this amazing things happens, just go to check the technical docs. Or if you're interested, I also had a talk that listed above. So that covers all that I want to mention in the streaming part. So next, I probably want to invite my colleague Lincoln for stream batch unification.
Yeah, thanks Yuan for his great talk. I'm Lincoln, also come from Alibaba Cloud. Now let's talk about the streaming batch unification. So what exactly is the stream batch unification? From a data engineering perspective, we can describe in one sentence. That is storing just one set of data and writing one piece of code to meet both real-time and offline data process needs. So one code also implies the requirements for the unification of execution engine, because even use SQL as the user API, we have still differences in different dialects. So the most straightforward way to achieve writing just one piece of code is to use one single engine. Now let's look at the real challenges in real-world data engineering architecture. On the left is the classic Lambda architecture. We can breaking down by layers. We have the data ingestion layer, which is responsible for the data into lakes or warehouses, and the data storage layer, and consisting of the offline storage and message queues. And the rest is the data development based on the specific computing engine. So from top to the bottom, we have two different tech stacks for the two pipelines. And this will lead several issues in development, such as high storage costs because of the storage redundancy and the complex tech stack. And for the users, they need to develop separately for both offline and real-time development. And this may cause potential data inconsistency. In recent years, the new unified stream batch lake storage, like systems like Paimon, often, they make the lakehouse architecture more useful. And the Paimon, like Apache Paimon, the systems supports both the streaming read-write and the batch read-write. Together with Flink engine, it can provide a continuously incremental update pipeline and make the pipeline greatly unifies the computation and the development. But there still remains some issue unresolved, such as when do data backfilling, the stream mode will be very slow. And if we want to use the batch mode refresh with better performance, then we still need to modify this original circuit. Then let's turn back to the perspective of Flink. Over the past decade, from the engine architecture of streaming batch unification to the production-ready circuit engine, we have achieved computational unification. The new Apache Paimon, it realized storage unification for streaming and batch. And Flink CDC provides a unified ingestion. So to implement a full-stack streaming batch development stack, what is still missing? The core issue to preventing the unification of stream and the batch code lies in the difference in different different programming models. Let's say the batch model, the batch processing is designed for the static data, typically involves the partition operation, such as insert override partitions, and each partition has defined filtering conditions. But streaming processing, on the other hand, it will deal with the streaming data, the unbounded data. It will not involve such partition operations, so it will be different with the batch circle. So to address these issues, we have introduced the new materialized table. Here is on the center, we have a simple script to create a materialized table. It consists of three main parts. The first is the create materialized table object. Then a Paimon table will be created under the Paimon catalog. The second is the data freshness. Users can set the desired data freshness as they need. The last part is the query definition, which describes the business logic. So with materialized table, users can use the declarative secure, and have a unified one. And the users just need to describe their business logic and set the data freshness as they need, and the rest part, the engine will handle the rest part automatically. So users when use materialized table, they can improve their maintenance work in addition to writing one piece of code. For example, during a promotion, we provide users with the second level real-time data. And after the promotion ends, in order to reduce operational costs, we can just change the data freshness to day level with a single click. And for the data backfilling, which is commonly used in data warehouse, and we can also trigger it with a single command. Yeah. Materialized table not only helps users to achieve writing just one piece of code, improving their development and maintenance efficiency, but also bring cost efficiency. Yeah. Materialized table supports 3 different refresh modes. The streaming mode, continuous refresh, the batch mode, full refresh, and also incremental refresh. Let's look at the cost curve on the right side. Yeah, the continuous mode, which is using Flink streaming mode, it can provide second level real-time data freshness. But the cost were not reduced significantly, even if we set the data freshness to our level. This is because streaming mode requires resident computing resources. And for the batch mode full refresh, it is the most cost-effective solution for data ranging from hours to days. And for those types of one-time computation, it is the best solution. But when we use full refresh to achieve minute-level freshness, it will be very costly because the full fresh mode will recalculating all data for each time. And the incremental mode, the fresh, it falls between the two, and it can reduce the cost by just calculating the incremental changes only. So, materialized table just complete the last piece of the puzzle for Flink's streaming batch unification, but this is not the end. We will advance the joint optimization for both computation and the storage layer. For the computation part, we will improve operator efficiency, which involves the new disaggregate state, and also offer more computation mode, and enable materialized data sharing. And for the integration of storage, we will leverage the new capabilities of the streaming storage, just do some more computation offloading, and also together with the new unified stream lake storage, we will aim to provide users a seamless switching from the second level, minute level to hour level operations. Yeah, this concludes the content of stream batch unification. Thank you all. Now let's hand the stage over to Xintong.
Okay, thank you, Lincoln, and thank you, Yuan, for the sharing. So next, let's talk about the streaming lakehouse. Okay, the streaming lakehouse is a new architecture as already introduced in Lincoln and Feng's sharing. It's a new it's a new data analytic architecture that we built with Flink and Paimon. And in this architecture is completely stream batch unified, and all the data in the streaming lakehouse are real-time and curable. But in order for this new architecture to well landed in production, it requires a deep integration between the two projects, Flink and Paimon. So we have been doing a lot in that direction. We have been improving the integration of Flink and Paimon in many commonly used scenarios. For example, in the white table scenarios, well, usually when people want to build a white table, they will use join operations. But join is kind of an expensive operation in data processing. So now with Flink and Paimon, in some use cases where the primary key is available, we can actually replace the join operations with Paimon partial update features. That will significantly reduce the computational cost. And also in some scenarios where we use Paimon as a dimensional table, we have also improved a lot made a lot of enhancement in that direction. For example, we have improved the performance of Flink's lookup join with respect to the data distribution inside Paimon. And also in order to handle the single key data screw problem, we have supported the Flink screw join optimization. And there's a new feature called processing time temporal join in Flink. This can be used in some use cases to replace the lookup join, especially in the use cases where the dimensional table is not frequently updated, and it also can reduce the computational cost. Well, we are also supporting some new emerging stream batch unification scenarios, such as data synchronization with Flink CDC and the materialized table, which Lincoln just introduced. And speaking for the engine capability, we have significantly improved the performance of reading data from and writing data into Paimon with Flink. For example, we have supported Paimon's delete vector, and the data ordering, and also some native file I/O implementations. And for maintenance, now that all the Paimon maintenance actions, for example, the compactions and the metadata cleanups, they can now be easily do with Flink SQL with the procedures, and the named arguments are fully supported. And also for the semi-structured data, which like the JSON or XML, those data are frequently, we see a lot in the AI and feature engineering scenarios. Well, we are also working on some techniques, for example, the variant data types, to speed up the read, write, and processing of the semi-structured data. That's for the Flink and Paimon integration. Well, the next topic, let's talk about AI. Well, this is actually through our interaction with the Flink community, with the developers and users. This is actually a very frequently asked question. So people would say that it's the generative AI, the large language model are so popular these days. So what can Flink do in this area? Well, let's look at this. This is a simplified version of the RAG architecture. And we know that the idea of RAG is to leverage some kind of knowledge base. For example, some internal data of an enterprise, or maybe some domain-specific knowledges. So RAG leverages such a knowledge base to assist large language model for content generation. Well, in this architecture, there's 2 steps. The first step is to prepare the knowledge base, and we use large language model to generate a vector for each piece of the data in the knowledge base. This is called the embedding. And with the generated vectors are stored in a vector DB. And in the second step, when the user query has arrived, we do the same embedding for this query to generate a vector, and we use that vector to search in the vector DB for the most related contents. And that is, and then we provide the query and the context together to the large language model for the content generation. Well, the question is, how can Flink help in this architecture? Well, we know that Flink is good at real-time data processing. So the question can be asked differently. It's like, is there any demand for the real-time data processing in this architecture? Well, I think the answer is yes. So firstly, the knowledge base is not static. It's keep being updated. So when we do an update to the knowledge base, we expect the result is reflected to in the generated content as soon as possible, and that requires depends on the real timeness of the blue pipeline in this figure. And also, when user submitted a query, it is expected that the content will be generated as soon as possible. Well, this highly depends on the performance of the model itself, but the real timeness of the purple data pipeline also matters. And we observed that in this architecture, there's a critical path. That is the invocation of the large language model for both embedding and the content generation. And in order to speed up this critical path, the Flink community has introduced the ML model invocation support in Flink SQL. So now Flink users can just use Flink SQL to create a model, just like creating a catalog. So we can define the input and output data structures of the model, as well as some model-specific arguments. And after defining this model, we can just use this model. We can invoke it inside your Flink SQL, just like using a function or table functions. Well, this will help integrate the model invocation together with the data processing and the validations before and after the model invocations. And this feature the design has already been approved in the Flink community, and it's currently under developing. And this is the first step that the Flink community take towards the generative AI area, and we believe that there will be more efforts towards this direction. So this is what we bring you today for the Flink 2.0, and thank you for listening.
Thank you, Mr. Sin Tong Song, together with Mrs. Yuan Mei and also Mr. Lincoln Lee for introducing us to the new version and what's new in Apache Flink 2.0. Since AI become global, I've been using AI technology for work and also for entertainment. I've tried to make a pantun from one of the apps of AI. Pantun is a traditional form of Indonesia poetry. So please bear with me and answer me with a word cakep ya Bapak Ibu ya. Bisa ya? Oke, pergi ke pasar membeli ikan. Ikan dimasak, makan bersama. Dengan AI jadi teman, cakep. Hidup terasa semakin menyala. Kasih tepuk tangan dulu dong ya. One more with English, ternyata bisa ya. Also answer me with cakep, okay? Climbing a mountain to the wait. Climbing mountain to see flowers. Beautiful flowers in red so bright. With AI as our daily helper, life become much easier and light. Kasih tepuk tangan lagi. Beneran ya Bapak Ibu, jadi lebih gampang dan juga lebih easy. Tadi buat pantun cuma ketik-ketik aja langsung keluar, tapi perlu adjustment sedikit ya. Tetap harus ada sentuhan manusianya di AI teknologi itu sendiri. Baik Bapak Ibu hadirin sekalian, kita mau lanjut lagi. We're gonna have our next agenda, but before that let me remind you with the social media challenge. Please now don't forget to post any thoughts or maybe you want post something about this event and follow at Flink Forward Asia and at Alibaba Cloud on LinkedIn or X Twitter. Don't forget to use hashtag Flink Forward, hashtag Apache Flink, hashtag Flus, and also hashtag Apache Paimon. Don't forget to post it before 3 p.m. today and you will grab a exclusive merchandise at 5 p.m. And also I will try to remind about feedback form. Bapak Ibu nanti ada QR code yang perlu Bapak Ibu scan di akhir main session ini. Jangan lupa langsung di scan saja, diisi secara detail dan nanti bisa ditukarkan dengan merchandise. Jangan lupa di capture dulu, lalu nanti di meja registrasi ditunjukkan untuk ditukarkan dengan merchandise dari Alibaba Cloud. Alright, continuing with our agenda. If the previous session we have 3 speakers, for this time it will feature a duo. So let's now unharnessing streaming data for AI-driven application with Apache Flink. The speakers is Mr. Ashish and also Mr. Swarup. Please put your hand together to Mr. Ashish and Swarup.
Hello everybody, welcome again to Flink Forward, the real time is the future. Along my side, we have Ashish, this is Swarup. We will be talking about how we can harness the streaming of data for the usage of in AI applications using Flink. If you can go to the next slide, please. We'll be very short and simple, three different sections. The first one, we will be talking about the evolution of LLM. Second one, we'll be talking about how we are going to, how Apache Flink can be used and stream data into the AI applications. And in the third step, we'll be trying to showcase you the structure of the layout of how marrying both LLM and Apache Flink will be done. Okay, let's get started with the evolution of LLM. How did the idea of the AI started back when it was, because AI has been there for 50 years, right? But LLMs has started recently, right? Back when Google has written a paper in 2017 saying that attention is what all we need. But before that, there were several statistical models also which relied on just the rule-based, where the intuition is still less, right? So, but the main reason we wanted to achieve this LLM concept was we want to make sure the machines will try to depict and mimic the actions or the human behavior, right? So that's when this whole idea of LLMs came in, and that's when the statistical models went in. That's when we will be talking more, but this is all pre-ChatGPT era. Let's talk about how the post-ChatGPT era, let's listen from Ashish about that.
Yeah, so I'm not going for last 50 years. Let's take a scenario for last 3 years. 2022, there was an explosion with ChatGPT, and people get to know about what is LLM is all about. AI and ML guys are aware about LLMs and everything, but after ChatGPT, there was a spark everywhere, and everyone is using that LLM-based solution. In 2023, it's all about the experimentations. So many major players were coming up with their LLM solutions, like Microsoft, Ali Cloud. So many guys are there in the market, and they are coming up with their LLM-based solutions. While as a developer, we are doing some testing, POC, and developing a prototype for our enterprise customer. Now, in 2024, the current year is about the year of production. Enterprise customers has adopted LLM-based solution. It's running in the production environment, and now we have full-fledged solution for LLM-based solution. Enterprise customers also has their KPIs, budget available for our LLM-based solution. As you can see in this slide, all the industry, whether it is banking, software, communication, media, traveling, video generation, everyone is using LLM-based solution. So what they are doing is they are having their data source in the form of text, image, audio, video. They are training their model. Model can be any LLM-based model, and they are developing the applications like content creation, Q&A chatbot. Then they have anomaly detection, risk management, and a number of applications are being developed for the enterprise-based customers. But as we know, like every positive has their own negatives as well. So let's hear about something like what are the negatives and challenges from Saurabh for LLM.
Thank you, Ashish. So there'll be a lot of to and fro, guys. Please bear with us. We wanted to make it more like a conversation, the whole interaction. So let's dive into what are the challenges we have currently in the LLM area, right? The first one would be the hallucination. The second one is verifiability. And the third one will be the knowledge cutoff. Because all the LLMs right now are being trained based on the existing data, right? And then they are not fed with the real-time inputs or the real-time data. So we would like to spotlight on these three. The first one, if you see in the example, I was asking the LLM, can you tell me the updates on Queen LLM? The first thing that it has, because the LLM was not trained on the latest data, it has hallucinated. Are you asking about the Queen Elizabeth? Or are you talking about the Queen Band? Or is it it started to hallucinate saying that, is it a fictional character? So this is one of the interesting challenge which we have found when, in the basic LLM. And also, the second one would be, which I was telling, since it didn't have the real-time data of when the elections happened, right? So I asked, do you know who won the US presidential election 2024? And apparently it said that it didn't know because it didn't have the data. Sometimes it will also say that the election itself didn't happen. So things like this happen. So these were a few challenges we wanted to, if you go to the next slide, please. So we wanted to focus on a solution that will actually help us in this kind of challenges. I think Ashish would be the right person to give an introduction on this. So yeah,
I think thanks to our previous speaker who has elaborated about RAG, retriever augmented generation. Now it will be easier for you. I won't go deep dive in this particular thing. Retriever augmented generation is like you will be retrieve your document from your data sources. Enterprise customers may have their data. They will getting the data from there. We will pass it to LLM, and LLM will generate the response on the basis of that particular document. What are the benefits of it? We will be getting up-to-date data, accuracy will be there, it can reduce the hallucination, and it is one of the efficient and cost-effective solution as compared to other option that is available in the market. So there are two-step process, already mentioned by our previous speaker again. So it's like a data ingestion and storage, and second would be retrieval and generation. So let's do a little bit discussion on these two steps. Saurabh can give a better understanding about these two steps.
So the first one would be data ingestion, right? So which means you're trying to create a knowledge base of all the data that's available, or till what are the latest information data points you want the LLM to know, apart from the data which it has been trained on. The first step would be to collect the data. If you can, the knowledge source. It can be of any format. Like I'm sure everybody knows that we have PDFs, Excel, CSVs, or images also. And then how it works is the whole data is being chunked using text recursive splitter or any other splitters, and then those chunks, using an embedding model, you will run into a floating point number, which is now called as vectors, and stored in the vector database. This is a concept which a machine can understand the relation between words or the position of the words, irrespective of where it is in the sentence. That is what vector database is really useful for when you are extracting. So since now we have the knowledge base, right? What will be the application layer? How does it look when we are retrieving the data from the vector database? Initially, when the user asks a query, the app sends the query to the vector database using an embedding model to retrieve the chunks that are required or relevant to the question. So when the retrieved chunks is come to the application layer, the application sends both query and the retrieved chunk to the LLM to get the answer. And then since the LLMs right now are text generation based on both the data points, it tries to answer and then it never hallucinates, because right now it has the context of just the query and the retrieved chunk. So that's when LLM answers back and the application layer displays out to the user based on that's the last step. And if you can go to the next slide, please.
I think after RAG, everything is resolved, right? All the answer will be resolved. So? Yeah, you can see like, we have an application. I asked about to review the logs to find the anomaly for our application. And LLM is giving the answer because it has.
Nice.
Yeah. You can see the answers is here from our application logs.
Okay.
So I think the issue is resolved, right?
But have you ever tried asking for the latest data of the logs?
Latest data.
Yeah.
Let me try.
Okay.
Oh.
See, let's say 1 hour before.
Oh, it's not there.
So how?
I mean, do we really need real-time data?
We definitely need real-time data. That is the main agenda of this whole event, right? So that if we are sending batches of data and trying to store it in vector database, it's still outdated because it's not real-time data. So that is where we want to bring Apache Flink. The benefits of real-time data, if you go to the next slide, please, we have written few benefits where the user experience will be definitely improved if we use the real-time data because he'll be updated with the current happenings. And also the data is agile enough to understand that what's happening in the current state. So let's understand, now we understood the RAG architecture, right? So now comes the big boy in the room, right? Apache Flink. Let's try to listen from Ashish on Apache Flink.
So I think everyone is aware about Apache Flink in this room. So it's an open source framework driven by the community. It helps for the batch processing data as well as real-time data processing is there. It can handle a large amount of data. And of course, it will provide a low latency. So if you are not aware about Apache Flink, this is the best platform. This is the best event. You can have the tech talks later on as well for the Apache Flink, and you can go through it and learn more about Apache Flink. So I can show some features that is available for Apache Flink it's an open source framework. Why we need open source? Okay, as a developer, yes, I need open source to design my solution as per my requirement as well. Streaming data processing is there, real-time data processing is there. It's a fault tolerant. It also helps you to do the batch processing as well. It has a distributed system. It has the state for operations are there. And the most important thing which may require for the real-time data processing, especially in the LLM, is low latency. So it has so many features out there, and we can utilize Apache Flink in our real-time LLM-based solution as well. So as you can see, the most important thing is here, like Apache Flink is something not only available in one of the provider. We have so many partners are available which are providing the Apache Flink. So most important thing is like seamless integration. So Apache Flink will be getting some data, and it will be sending some data to some other sink as well. So we can say like source and sink. So if you will see, there are so many providers available in terms of sending a data to Apache Flink. It has a seamless integration with so many providers that is available in our market. Then Apache Flink will do the processing, analyze the data, and it will send the data to our sink. And then you can see, again, all the number of partners or the service provider or the services are there where we can send our data to those kind of service providers as well, or the services, I would say. The next thing is, whenever we are developing an application, it's very important how we are going to deploy that solution. Okay, so people will say on-premise system, some will say managed cloud, and some will say, okay, we will utilize our third-party vendors. Apache Flink is having a feature that can be deployed in n number of solutions, whether it is Docker, Ali Cloud, any service provider, whether it is with the third-party vendors like Decodable or Veriverica, it can be deployed everywhere, and it provides the seamless end-to-end integration. So that's why Apache Flink is a key player when you are looking for a real-time data streaming-based solutions. So the last topic is implementation. That is quite important. How we are going to do this kind of implementation with Apache Flink and LLM. Before this, we have to see what are the components and the layouts are available to develop our LLM-based solution. So it would be like a high level. And we can see like we have our data sources available, data sources from IoT, application, mobile apps, and any other services as well. We will be having a Kafka. Then we have our Flink. Embedding model is available. It can be our open source or closed. As per your requirement, business requirement, we will be having vector databases where we are going to store the vector. And then LLM, any LLM is available. We are utilizing Twin in this example. And there will be a user who will be asking so many queries, and it will be getting a response from them. So we can I think Saurabh, you can just tell more about the end-to-end solution, and maybe it will be useful for them as well.
Right. Now that we saw the components, what happens is this is how the flow or the architecture we wanted to implement for the streamlining the live real-time data. So the data source will be coming from different web data points, and then we'll be streaming it through Kafka, which will send the topics into the Apache Flink, where as we have heard from the previous talk, the async IO data inputs will be sent to the embedding model, and then they will be, we learned from the RAG architecture, right? The embedding model will be trying to send the data convert them into vector database. And the vector database will be continuously updated based on the real-time data. When a user actually asks for a question, it goes directly to the embedding model, and then the embedding model will retrieve the chunk and give the answer accordingly based on the query. It can be, in this case, we wanted to showcase the queen, and the queen will be answering the user based on the query that the user has implemented. Having said that, we actually thought that this is an interesting architecture we wanted to work on, but we thought let's also try to see the other side of the coin, and also talk about what are some of the considerations and challenges we'll be facing while implementing this. As the people from the open community, right? So we wanted to consider the latency because each module has different kinds of response time and inference levels. So based on that, we need to consider that and where we are trying to run these situations, instances. At the same time, when we are dealing with huge data sources, there is definitely a problem model complexity. And if you want to fine-tune it more to a particular set of instructions, then there will be definitely bias and model overfitting issue. So that is one thing. And definitely everybody, as talking, it's called the ethical considerations are also important to take care, because the guardrails must be in place to make sure it's not going out of the context, or the real-time data is not misused in case of it. Having said that, I think we would like to end this presentation. And thank you so much for listening to us. That's our presentation.
Yeah, I think I would like to thank our organizers to giving us an opportunity in this platform to share about our use case that we have presented here, how to develop this LLM. I think Apache Flink is something that we are utilizing in most of the company, whether it is enterprise or small scale companies. Kudos to our organizers, everyone, and especially the community, because if the community will work, our solution will grow, and this will help us to solve our day-to-day problem, whether it is enterprise or any other industry. So thanks a lot, guys. Yeah, that's
Thank you again.
Yeah.
Thank you so much.
Thank you, Ashish and also Subaru, for the presentation of the future of real-time streaming of data to LLM, ladies and gentlemen. Next one, we have about Paimon 1.0, Unified Lake Format for Data plus AI. It's a package with also Flink. Ladies and gentlemen, this presentation will be delivered by Mr. Jing Song Lee as Head of Open Source Lake Storage, Alibaba Cloud, Apache Paimon PMC Chair, and Apache Flink PMC member. So ladies and gentlemen, please welcome Mr. Jing Song Lee.
Hello everyone, my name is Jing Song Li. Today I want to share something about payment, or also aka payment. Okay, I worked in Flink community, and now I'm focused on lake format Apache payment. So at first I want to ask you 3 questions from big data workers. I asked many companies workers. They told me there are 3 main questions. So the first question is, we have launched, we have started many real-time applications. We are using Flink and Kafka and Flink system and KV system and OLAP system. But current days, the cost is becoming more and more important. So actually, we want low latency, and then we also want to low cost too. So we want both low latency and low cost. This is the first challenge. So the second challenge is now there are many big data frameworks, many storages in big data systems. So if there are many data in many systems, so if you want to do something special or you want to do, you have many batch data, you want to do some streaming to do some real time, you must move data from batch system to Flink or to Kafka or to OLAP system. So there are lots of frequent data movement, and actually you are very difficult to develop the data. So, and the complex architecture, it is hard to maintain so many systems. So this is the second questions. And the third question is data for AI. You know, we already talk about it. AI is very hot, and AI also has its AI infrastructure. Actually, for our big data system, we also want to be the infrastructure for AI. So how big data and AI have some relationship, and we can do some combination. So these three questions. So I want to talk in China now. Yeah, today Jakarta is very hot, and actually in China it is winter now. It's very cold. In China, in big data system, we already have very many companies. They are using Paimon to build a unified data lake storage. We know in the whole world, actually in big data system, the lake format is very hot. And in China, Paimon is very hot. So how to use Paimon? So for the first question, you want low latency, you want a low cost. How to do it? You can use Flink and Paimon to build a streaming lake house. And you can, because you allow using Kafka, the queue system, the Kafka has a server, Kafka has its SSD storage. And you may use some OLAP system, KV system, they are all online system. Or it is very fast. They are very fast. They have very low latency, about seconds latency or milliseconds latency. But the question is that you really want milliseconds? Actually, for the real business, actually minutes seconds are most of your case. You just need minutes seconds latency. So you can use Flink and Paimon. Paimon, it is a lake format. It's based on the file system, something like you can use HDFS, you can use OSS object store, you can use S3. So Paimon is cheap, and you can use Flink and Paimon to streaming read, and to achieve low cost of offline batch data accelerate. So this is the first question. So the second question is, actually Paimon today provide many features to support batch processing, to support streaming processing, and to support OLAP processing. So actually in our company, you can just have one unified storage system that you can use Paimon to build a unified storage for streaming, just like Flink for batch. You can just use Spark, and for OLAP, you can use Starlocks. So you can build one unified architecture, and in this way, you don't need to use other system. You can do all computation on one storage system. So this is for second question. For third question, data lake and AI actually has done many features to make AI happier. Something like Paimon also provide Python API. You know about it. In AI world, Python is really important to AI. So Paimon provide Python API to allow Python SDK to read data from Paimon to write data into Paimon. And then Paimon also introduce interesting feature, element object table. Object table is something you can just mapping a location on OSS or S3 to a payment table. And then you can just read this payment table. You can read all unstructured data. So it is very interesting. It really bring unstructured data into the lake format. So what is payment? So I bring these three graphs. So first I want to introduce Hive. So what is Hive? I think Hive is a shared file storage for batch processing. You know, Hive just a directory. There is a directory in it. There are many org files or Parquet files. It is very simple architecture, and it just provides the basic functionality. If you are using Hive, you know about in batch processing, you can only use the insert overwrite to overwrite a partition. Of course, you can use insert into, but insert into has many problems, just like data missing or data duplicated. Yeah, it will cause many problems about the data consistency. So only way to use Hive storage, I recommend you just use insert overwrite. So we know Iceberg Hive storage is not so good. So Iceberg comes. Iceberg, I think, is a shared database storage for batch processing. Based on the top of the Hive, Iceberg provides more features, just like ACID, transaction. In Hive, you can only use insert overwrite, but for Iceberg, you can delete, you can update, insert some record. So there is guarantee about data consistency. You don't need to care about there will some data loss. And then Iceberg provides something like data skipping. Iceberg controls every file, controls the metadata, record the metadata of every file. So it can do some data skipping based on min-max of the columns. And then Iceberg managed the snapshots of the table. So it can do, you can do some time travel query on Iceberg table. So this is Iceberg. I worked in Iceberg community 2020, and we in Alibaba we contributed Flink Sync into Iceberg community, and we also contributed Flink SQL integration in Iceberg community. But then we found that Iceberg is not very good to streaming processing. Why? Because Iceberg is designed for slow changing data. So for streaming, it is not, the initial design is not for streaming. So we developed the Paimon. So Paimon is a lake format for streaming, or you can say for Flink streaming processing. So Paimon is a shared database storage for not only batch processing, but also for streaming processing. We combined the lake format and the LSM log structure merge tree. LSM is the best structure to update. And we integrate Flink to streaming write, streaming read, automatically compaction. You don't need to care about small files. It is very useful. And we also introduced the deletion vector feature on the top of lake format. So OLAP query, Spark query, or OLAP query can query the update table very fast. So let me just explain what's the difference between Iceberg and Paimon. So, you know, what is Iceberg? So Iceberg is iceberg in the lake. You can imagine an iceberg in the lake. On the top of a lake, the iceberg should not be so big. And under the water or inside the lake, the iceberg is very big. And you can imagine how can you make iceberg very fast? You can imagine iceberg, something iceberg can move very fast on the data lake. Can you imagine that? I think it's very hard, unless you must have a very super power engine to push the iceberg. But the payment, the payment, the logo of payment is sailfish. So, sailfish, what is sailfish? Sailfish is the fattest fish in the lake, in the sea. So I think for the initial design, payment is designed for streaming and payment is fast. So I have talked about it. Payment, many companies in China, in Chinese community, has used payment into their production environment. So I think payment is most popular lake format in Chinese community. I've seen many companies, more than 10,000 Flink jobs and Flink and payment to build a streaming pipeline to improve business timeliness. And I know in this year, newly enterprise adopted more than 100 enterprise has been adopted by numerous enterprises. And in this year, payment also continues in innovation into 2024. And many new innovative features comes in payment community. And we have more than 200 contributors. They come from Alibaba, Buy the House, TikTok, Vivo, Shopee, and Xiaomi, and more companies. So this is the development history of Apache Payment. So payment initialized in Apache Flink. It is Flink Table Store. It is a sub-project of Flink. And its original is Flink Table Store. It's the original design for Flink streaming on the top of lake format. Yeah, and then we found that lake format, you know, what is the best feature of the lake format? It is open. It shouldn't, so payment should, Flink Table Store should not just be a sub-project of Flink, because the open, yeah, we should open the Flink Table Store to more engines, just like Spark, just like Starrocks, just like Hive and Trello. So Flink community contributed the Apache Flink Table Store to Apache Incubator. And the payment comes and becomes Apache Incubator project and open to other rather than Flink, Spark, Trello, and others. And this year's, payment just become Apache top level project and graduated from Apache software. And we have a very integration with Flink, Spark, Presto, Trello, and more computer engines. And in this month, we want to release Payment 1.0, and it is coming. And it should be a unified lake format, and unified for streaming, for batch, for OLAP. And we have introduced a lot of features, just like view support, list catalog, and iceberg snapshot. So this is progressing in Alibaba. Yeah, Flink and payment in Alibaba this year have very great progress, and I'm very excited to introduce this. We have moved to big table from old warehouse to payment lake storage. One table is page view. You know, every application in Alibaba will produce the page view, and all page view will be collected to one table. That means page view table. And another table is orders. Yeah, every will produce orders. So these two people, or most of analytic business are based on these two people, these two tables. So I'm very excited to move these two people and related business into lake format to streaming lakehouse. So the storage of payment almost 100 bytes, and the max record per second for that page view table are more than 40 million per second. So the old architecture, something like Flink and Kafka, and combines stateful streaming. So its character is seconds latency and real-time ETL. And the disadvantage is that the streaming and batch separated. It means you must write a streaming cycle, streaming pipeline, and then you must write a batch pipeline. And two works are very complex. And then Kafka cannot query it, because Kafka is something in a queue. It cannot be queried. So the Billy's ETL, the Billy's OLAP cannot query the real-time data. And third is it is hard to reuse middle data, because Kafka is something like queue. You cannot reuse the queue very easily. So this architecture has moved into Flink and Paimon to build the streaming lakehouse. So the character of streaming lakehouse is it is minute latency. It means some business you don't need to seconds latency or milliseconds latency. You accept minute latency, and into streaming lakehouse architecture, all tables can be queried in real time. And the streaming and the batch can be unified, because for the same storage, same computation engine, Flink. So the Flink cycle can do streaming cycle, Flink cycle can do batch cycle too. The cycle have been unified, the storage have been unified. So the advantage is that the unified storage and all tables are open and can be queried. And actually, you can also use payment to do some duplicate. ODS, DW, the initial tables in the data lakehouse can be deduplicated in real time. So after we did the migration, Flink and Paimon in Alibaba, this is the benefits. So benefits is batch processing. The first table has been changed into streaming from batch. So the latency, so we achieved 1 hour ahead of schedule. Latency had been reduced. And the development and operation efficiency can be improved in over 50%. And all tables can be real-time OLAP analysis for business BI. And we also introduce real-time data deduplication, and this can greatly reduce the cost. So the last one is Paimon use DFS, something like object table store, object store, something like S3, VS, Kafka, SSD. It can greatly reduce cost. So next, I want to introduce the ecosystem of Paimon. So for the SQL query, you can use Flink and streaming SQL or batch SQL. You can use Spark SQL. You can use Hive, Starks, Doris, Trello, and something like these open source computation systems to do SQL query, SQL write, and SQL maintain. And you also, Paimon community also introduced the CDC ingestion. It is very easy to CDC ingestion from Kafka to Paimon with schema evolution. That is very convenient. And also MongoDB, also MySQL, Pausa, and PostgreSQL. And then in 1.0, we also introduced Python API on top of for Paimon. So through Python API, we can unlock many Python ecosystem, just like Arrow, PyTorch, Ray, Pandas, and more. So the ecosystem is not enough. It is enough in China if you if you are using Alibaba Cloud, so you will find everything is good. But if you are using AWS or some external, some enterprise computation engines, just like Snowflake, Athena, and BigQuery, you will find these computation engines cannot support payment. So what we should do? What we should do is we introduced Iceberg snapshots in payment community. So through an option, you can enable Iceberg snapshot to let payment to produce Iceberg snapshots for all tables. So through this, we can let Iceberg computation engines to query data from payment, just like you can use Snowflake, Athena, Impala, BigQuery, Presto, and Dremel, and all Iceberg ecosystems, including Python API, including Rust API. So next, I want to share about some Python API of payment. So we called it Paimon. Yeah, we actually at the beginning of development of Paimon, we have two options. The first option is we can re-implement or in Python as Python language, but payment is very complex. It has primary key support, it can merge engine, it has LSM, long structure merge tree. So another way is using Py4j. So Py4j is a very good lib you can run JVM in Python. So and another lib is Arrow. So Arrow is a very, very good lib you can exchange data between two languages. You can produce data in Java and pass the data into Python, and you can generate the data in Python and pass data to Java. So through these two technologies, we have introduced this Python SDK of Paimon. And it has full features of payment. It has catalog API. You can use it to read data from Paimon. You can use projection. You can filter, push down, and you can write data into Paimon too. So this is an example of using Paimon. So it's an ecosystem through Python API. You can unlock all Python ecosystem, including PyArrow, including Pandas, including DuckDB, and Ray. So here is an example to use Paimon. You can declare a catalog and get a table and use a new read builder with a projection and scan data and read data into Pandas and analysis data from using DuckDB. So finally, I want to introduce object table. I've talked about the object table. So object table means that we can manage unstructured data in the structured way. Yeah. If you have many unstructured data in OSS bucket or S3 bucket, yeah, you have some JPG picture, you have some movie, you have some text, you have some MP4. And you can use a Paimon object table to mapping the metadata and through refresh into a Paimon object table. You can see the Paimon object table is a structured view, and it has many columns, including path, name, and modify time, access time, and MD5. So through this table, you can use something like a PySpark or Flink Cycle or Spark Cycle to analyze the unstructured data. So here is the example to PySpark filter images and convert the unstructured data to PDF. So you can use a Spark session, PySpark, and you can get the object table, and you can do some filter, and finally you can convert one by one to PDF. So here is the example. So thanks everyone to listen from me. It's So I recommend you to just try about the payment. You can click this website to payment website, and you can download the payment link and try it. Welcome to just chat me to let me help you. Thank you.
Thank you so much, Mr. Jing Song Lee, for the presentation on Payment 1.0. Ladies and gentlemen, there will be another last session. We have a last session on Flux, next-gen streaming storage real-time analytics that will be presented by Mr. Jark Vu as head of Flink SQL and Data Channel, Alibaba Cloud, Apache Flink PMC member. So this is for the last one. Please welcome Mr. Jark Vu.
Good morning. I'm the last speaker of the keynote, so I think I will go through my slides quickly so we can have lunch early. I'm Jark Vu from Alibaba Cloud. I'm leading a Flink SQL team in Alibaba. And I have been working on Flink SQL for over 8 years. And in the 8 years, I put a lot of effort in Flink engine to make the streaming analytics easy and affordable. But we found a lot of challenges that it's hard to be resolved just from the Flink SQL side. So we started to look into the storage to make the storage and computer engine together to resolve some problems. So we started the Flux project since 2 years ago. So nowadays we can see a significant change in that big data is moving from offline to real time. We can see a lot of different use cases and industries is having the real-time evolution to help the business better. And you may feel the technology changes more deeply, that the big data architecture is moving from the traditional hive warehouse to a modern lakehouse architecture, and to now to the Paimon streaming lakehouse architecture, which is very famous in Flink community and in China. The motivation of the architecture evolution is users want to have more real-time data and to gain real-time insights and to help the decision more quickly. So we can see the data latency is changed from T+1 day to T+1 minute to T+1 hour and to T+1 minute. However, data lake is a technology based on object storage, which is limited to minute latency. But there is still many business that requires second latency, such as the recommendation, advertisement, anomaly detections. So a second level storage is strongly needed in the industry. And we can see, but there is no such a good low latency storage that is easy to use in big data analytics. So what is the most commonly used real-time storage for the big data? It is Kafka, which is most commonly used in nowadays. And Kafka and Flink is the typical architecture to build the real-time analytics nowadays. But Kafka and Flink is not a good solution, because if you are using the Kafka in big data analytics, you will have a series of problems. The first problem is Kafka doesn't support update. And update is a very, very basic feature in data warehouse that you may want to update or fix some data, but Kafka doesn't support it. And Kafka has to store all the duplicate data on the primary key in Kafka. And when the compute engine to consume Kafka data, it will receive the duplications. So computer engine, in order to guarantee the correctness of calculation, computer engine have to do the deduplication before the calculation. And the deduplication is very, very cost a lot. For example, Flink will use the state to materialize all the input data in state. And this costs a lot of money. And every time you consume the Kafka topic, you have to pay the cost again. So this makes Kafka data is hard to be reused by the businesses. And second problem is Kafka is hard to debug. Because Kafka is not queryable. Query is also a very foundational feature in data warehouse. No matter you want to do some debug or some arbitrary data exploration, you need to query the data. But Kafka doesn't support it. So there is two solutions. The first one is you can dump the Kafka data into an OLAP system and just query the OLAP system. But it introduced many, many moving parts, and of course it is expensive. And it is hard to guarantee the data and it is hard to guarantee the data consistency between different systems. And the second way is you can query the Kafka data directly with a query engine, such as Trino. But remember that Kafka is scannable, not queryable. So Trino have to do a full scan on Kafka, even for a very simple query. And Kafka doesn't support any data skipping. So it is very slow to do a very simple query. For example, if you want to query 1 GB size Kafka data with Trino, you may take over 1 minute. So it is, of course, not scalable and not available for large scale data. The third problem is processing historic data. So also called backfilling. Backfilling is very common in data warehouse. For example, logistics usually requires to backfilling data from things several months ago. But Kafka doesn't support to retain so long data. It usually retains data for a few days. And when you are reading history data from Kafka, all the data will go through the Kafka broker. It will make Kafka broker very unstable and occupies the Kafka's CPU, pollutes the Kafka broker's cache, and disrupts the live traffic. The last problem is networking cost. Networking cost can account the majority of the Kafka infra cost. But when you consume the Kafka data, most cores are not really used. Take Alibaba as an example. 49 cores are not used in more than 20,000 Flink SQL jobs in Alibaba. But you have to read all the data from all the cores from Kafka and pay the 100% networking cost. Of course, this is not very, very efficient. So we can see Kafka have a lot of problems, no update support, hard to debug, history data processing, networking cost. So this makes Kafka and Flink is not a good solution. So why Kafka doesn't support these features? Is it possible to add these features on Kafka? But we can see that Kafka is designed for streaming events, not for streaming analytics. So every product has its own positioning and strengths. So Kafka is designed to be a black box to store every kind of data from different applications. So it doesn't have schema. It doesn't have built-in schema, but schema is very, very important for analytics. And Kafka stores data in CSV format, JSON, Avro format. They're all raw format. But analytics requires to work on a large scale data, and it requires the ability to skipping data. But raw format is not good at data skipping, and column format is preferred for analytics. So we can see an interesting thing that if we draw a matrix, that the left side is operational system, the right side is analytical system, upside is stream storage, and the underside is table storage. We can see that operational database and operational streaming storage are all raw format. And the analytical storage like Iceberg, Snowflake, both use the column storage. And we can see there is a missing part in the matrix, and that is the streaming storage for analytics. And as expected, it should be a columnar format. So we started a project to fill the gap in the market and want to fix the problems in streaming analytics and for Flink. So we named the project Flink Unified Streaming Storage, and a short name, Fru, which comes from the first letters. And very interesting, Flink is a German word meaning fast, and Fru is also a German word meaning river. So we hope Fru can support streaming data that flowing, converging, distributing, just like a river. So I will go through key features of Fru. And the first feature is, as expected, it is a columnar stream. And so in the file format, we use Apache Arrow IPC streaming format to store the data. Apache Arrow is a very excellent streaming columnar format. We use the Apache Arrow to do the to get a very awesome projection pushdown performance, and meanwhile still keep the sub-second latency for reading and writing. And the right hand is the benchmark for Fru and Kafka. We benchmarked the read throughput for reading different numbers of columns. You can see that, and the blue line is Fru, green line is Kafka. You can see that when you are reading less columns, you will get better performance in Fru. And you can get 10 times reading performance compared to Kafka if you only need to read 10% columns. And all the projection pushdown is happened in the server side, so only the needed columns will be transferred to client side. So the networking cost will be reduced a lot. And the second thing is the updates and change logs in Fru, which is a very important feature that is required by Flink and the streaming analytics. So the foundational of Fru is a log template that provides streaming read, stream write as a streaming storage. And on top of that, we built a Kiwi template, Kiwi index on that to support high performance update. And the Kiwi and log is just like a stream table duality that Kiwi will, the updates on Kiwi will generate change logs, and change logs will written into the log. And during recovery, the log data will be used to recover the Kiwi template. So you can think, and the Kiwi template is actually a LogsDB LSM tree. So you can think Fru is it combines the streaming log and the LSM tree together to support large-scale real-time updates. And also, Fru support partial update, which can be used to enrich write tables very efficiently. And the change logs generated by the Kiwi can be read directly by Flink, and without any deduplication cost, which saves a lot of computing resources. And the Kiwi index we built on top of that can support us to support high performance prime key lookup. So you can use Fru as a dimension table or code reference table to enrich your streaming data in real time with the Flink lookup join. And we also support the limited query, count query, and point query to make the flows queryable and make the flows easy to debug. And a very important feature in flows called unification of string and lactose. You may know the Lambda architecture, which requires to duplicate data in the batch layer and the streaming layer. With the unification of string and lactose, it is some kind of kappa architecture, which unifies the data streaming and data lakehouse. So it can avoid the data to be stored twice in different systems to avoid the cost, to reduce the storage cost. So at the bottom, Fruits maintains a comparison service, and this service will continuously, automatically to convert the Fruits data into a data lake format. And actually, it is just a convert from the arrow file into a PACWI file and commit them into a table of metadata. So it is very efficient. And the key feature here is called shared data. So the lakehouse storage and the streaming storage can share data with each other. So on the underside lakehouse storage can be the history data layer of streaming storage to store long-term and minute latency data. And the upper side streaming storage can be the real-time data layer for the lakehouse, which stores the short-term and the second-level data latency data. And the data is shared with each other and exposed with only a single table. So when users reading the single table, he can use the lakehouse storage as the history data to have a better performance to catch up read. And when you want to batch analyze on the lakehouse data, you can use the real-time, you can use the streaming storage to provide the real-time data within the minutes. So the analyze on the lakehouse can be a truly real-time analytic on real-time data. And the converted lake table is in open table format, such as Paimon or Iceberg. So your existing query engines, such as Spark, Trino, Starrocks, can directly query or analyze the lake tables on the lakehouse storage. So here is the overview of Fruits, overview architecture. Fruits is a streaming storage built for real-time analytics. Fruits needs to maintain a server cluster which provides the streaming read, streaming write, and the real-time updates. And it leverages a remote storage for data tiering to reduce the storage cost. And underlying it deeply integrated with the lakehouse architecture to provide rich querying abilities. And the core features of Fruits including real-time read-write with sub-second latency and the streaming updates and projection pushdown to have 10 times reading performance improvement. And you can subscribe the change logs, and you can have lookup queries and the unification of string and lakehouse. So there are many interesting things I want to share about the future plan of Fruits. But I think these three things are most important. And it also tells the relationship between Fruits and the other three open source softwares. The first thing is Kafka protocol compatible. So it can help the existing streaming data to be migrated to Flu's easily. And the second thing is we want to deeply optimize with Flink to build streaming analytics better. For example, we want to support more push-down optimizations and make the rule-based optimizer in Flink SQL into a cost-based optimizer to leveraging the statistics in Flu's tables. And the third thing is Flu want to be the real-time data layer of Paimon and Iceberg. With the unification of string and lakehouse, Flu and Paimon can be a Kappa architecture solution to unify the data storage. And I'm very excited to share that Flu is just open sourced on GitHub last week. So it is open sourced under Apache 2.0 license, and we plan to donate it to Apache Software in next year. And it was just open sourced in last week, and we already have over 700 stars, I think. So you can, of course, to visit github.com/alibaba/Flus to visit this project, to try the core features I mentioned before. And we will also have a quick start in there to help you download and try the features. And welcome to join the community to contribute code. And of course, don't forget to give the project a star if you like it. And yeah, thank you very much.
Thank you so much, Mr. Jarkvu, for the last one about Flus. Flus is the German river. So that's a real-time efficient for analytic and just opened source last week. So please you can visit the project, and also don't forget to visit the GitHub link. We are so excited to see that Alibaba Cloud announced it has open source Flus on GitHub. You can now welcome to start Flus GitHub repository today and post your thoughts about Flus on social media with hashtag Flus. It's easy, right? And also we would like to send a huge thank you goes out to all our partners who have tirelessly supported us in bringing this event to life. Our technology partners, Elastic, Ocean-Base, and Seller Data have been instrumental in enriching our understanding of the data technology and also application. We also want to express our gratitude, ladies and gentlemen, to our community partners, Data Science Indonesia, Connect Tech, Ladies in Tech, Female Geek, Block Dev ID, and Python Indonesia. Your dedication and support in fostering a vibrant community around the data and technology are invaluable. Bapak Ibu hadirin sekalian, Dora ingin mengingatkan untuk Social Media Challenge, jangan lupa untuk join dan juga post sebelum jam 3 sore untuk mendapatkan eksklusif merchandise menarik dari Alibaba Cloud dan juga Flink Forward Asia 2024. Jangan lupa juga untuk saat ini boleh scan QR Code yang ada di layar. Kami mohon kesediaan Bapak Ibu untuk boleh mengisi feedback form dari kami. Sudah ada di belakang? Nah ya Bapak Ibu sekalian, silakan di scan QR Code-nya dan mohon diisi dengan lengkap sebelum Bapak Ibu keluar dari ruangan ini. Saran dan kritiknya tentu sangat membangun untuk event-event Alibaba Cloud dan juga Flink Forward Asia. And a little bit housekeeping, ladies and gentlemen, during you fill in the feedback form. As we approach the breakout session at 2 p.m., we kindly remind all speakers to be in their respective breakout session room by 1 p.m. To all speakers, please stand by in the breakout sessions room in 1 p.m. All right. Ladies and gentlemen, distinguished guests, thank you very much for your attention and active participation throughout this morning session. Can we give a big round of applause for you and all the speakers this morning? We will now take a break for lunch. For lunch, we have prepared a buffet, the outdoor area. Outside this room, we invite all participants to enjoy your lunch. And please note, after that, at 2 p.m., we will continue for the breakout session. We kindly ask your cooperation to return in time at 2 p.m. to the breakout location. For those who need any assistance, please call the registration desk. Once again, enjoy your lunch and see you at the breakout session. Ikan hiu makan strawberry. Jangan kemana-mana, tetap di sini. Kasih tepuk tangan Bapak Ibu sekalian. Terima kasih, sampai jumpa lagi. Baik, mohon perhatiannya Bapak Ibu hadirin sekalian karena kami akan merubah setting ruangan menjadi breakout session. Untuk itu silakan membawa serta seluruh barang bawaan Anda. Sekali lagi jangan meninggalkan barang bawaan Anda di dalam ruangan main session karena ruangan akan kami ubah settingnya menjadi breakout session. Kami mohon kerjasama dari Bapak Ibu sekalian untuk membawa serta barang bawaan Anda during this break lunch. Selamat menikmati santap siang Anda. Sampai jumpa lagi nanti jam 2 tepat. Terima kasih. kindly attention to all speakers. Once again, kindly attention for all speakers. We kindly request your presence in the main ballroom at this time for a group photo. Once again, to all speakers, we kindly request your presence in the main ballroom at this time for a group photo. Thank you for your cooperation.